Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 1 to 5 of the Algebra 1 Common Core New York Regents exam for June 2015. All right, let's take a look at problem number 1. It reads, the cost of airing a commercial on television is modeled by the function C of n equals 110n plus 900, where n is the number of times the commercial is aired. Based on this model, which statement is true? Now, one tip for solving problems like this when you have a model being represented in a linear form is that the slope-intercept form for a line y equals mx plus b can also be used to model the base price b plus the price for each unit m for x total units, okay, as we will do in this problem. The steps we're going to use are as follows. First of all, we're going to identify the base cost and the cost per each unit using the y equals mx plus b format. Then we're going to convert the equation into verbal form, okay, using the base price and the cost per each unit. Now, let's write down the slope-intercept form for the equation of a line that you're familiar with, y equals mx plus b. When using this model to model costs, when you have a base price and a price per unit, m, which you know as a slope, is the price per unit, okay, or price for each unit. X represents the number of units, okay, number of units. And guess what B represents? B is your base price, okay? How much you have to pay regardless of how many units you generate. Base price or base cost, all right? So y equals mx plus b can be broken down into these components. Now let's take a look at this situation we have here. We have C of n is equal to 110n plus 900. Now, do you see that this equation is in the y equals mx plus b form? Do you see that? Well, let me make it obvious for you. This output is y equals m is your 110, x is the n, and b is your 900. Okay, so this goes there, that goes there, and that goes there. All right? Okay, so we're just focusing on the right side. What is 110? 110 represents the price for each unit, okay? Cost per unit. So let's write it down. This is the cost per unit. And then the n, this n right here represents the number of units, okay? Number of units. And then 900 is a base price. 900 is a base price. Now, in this case, we're looking at commercials, all right? So we're going to contextualize the situation in a minute, or let's call it base cost. Okay, so now let's go ahead and write down what each piece means. We're going to express the meaning of this in verbal form, okay? So what does do all these components mean? So it tells us that the cost to produce a commercial, the cost to produce a commercial is what? Well, you have a base price of 900, so you have a base cost of 900, right? Plus what? 110 cost per n units. What is another way of saying that? $110 for each unit that's aired, each unit of the commercial that's aired. So you have a base cost of 900, regardless of how many commercials you aired, plus 110, the unit cost, times the number of each unit you aired. Okay, so that's what this model is telling us. So let me just show you some iterations of the situation just to make sure you understand what's going on. So let's say you air one commercial. What is that going to cost? It's going to cost you 110 times what? The number of units you produce, which is 1, plus the base price, which is independent of the number of commercials you aired. Okay, and then you add it up, you have 1090. What if you aired two commercials? What would that be? That would be 110 times what? The number of units you aired, which is 2, plus 900. Okay, and it's the same thing as adding 110 to this situation right here. Oh, just a quick correction. This is not 1090, this is 1010. So this is 1010. Okay, and then this is 220 plus 900. That gives you 1120. Okay? Now, let's take a look at the options we have. Which one is consistent with our verbal the explanation here? It says, the commercial costs $0 to produce 110 per airing up to 900. That's not correct. That's not what we have. The commercial costs 110 to produce and 900 each time. That's incorrect because in our model is 110 each time. 110 for each unit. 900 is the base. So this was kind of switched around. Okay? This is supposed to be 900 and that's supposed to be 110. Okay? So what does that mean? Option 2 is wrong. Number 3, the commercial costs 900 to produce and 110 each time it is aired. Exactly. This is what we want. Okay, let's look at our model again. Because to produce a commercial, you have a base cost of $900 plus 110 for each unit aired. Okay, so don't forget, it's just like the y equals mx plus b equation. M is the price per unit, and B is the base price that's independent of the number of units produced, okay? So our answer for number 1 is option number 3. Okay, let's take a look at problem number 2. It reads, the graph below represents a jogger's speed during her 20-minute jog around her neighborhood, okay? So we have the graph here, speed goes up, stays flat, up flat, down flat, up flat, and then back down. So the question is, which statement best describes what the jogger was doing during the 9 to 12 minute interval of her jog? So from 9 to 12 minutes, what's the jogger doing? Now, one thing you want to note is that the slope of a speed versus time graph, that is what we have here. We have a speed versus time graph, okay? The slope, positive, negative, or 0, 0 means no sign, tells you if the speed of the object is increasing, that's a positive slope, decreasing, negative slope, or the speed is constant. In that case, you have a 0 slope, neither positive nor negative, okay? So all we're looking at in this problem is the sign of the slope of the specified interval, and using that to describe what the jogger is doing, okay? All right, so steps. First of all, we're going to determine the sign of the slope on the graph on each interval. I will show you what's happening on each interval just to make sure you really understand this problem. And then we're going to use the sign of the slope to determine what is going on the specified interval. Okay, so I made the graph a little bit bigger so that I can really explain what's going on so you can understand. So what's going on each interval? So at the beginning, what's going on here? At the start, if she's moving 0 miles per hour, at this point, she's still, okay? She's standing still. She isn't moving. And also at the end of a 20-minute interval, the speed is down to 0, so she's still standing still. Okay, so still. All right. At every other point in the next 20 minutes, she's moving. Why? Because the speed never comes back down to 0. Okay. All right. So from 0 to 2, what is the orientation of this slope? So let me show you something real quick. From left to right, remember you always read slope from left to right, all right? From left to right, if a line is going up from left to right, that is positive slope, okay? It's like you're going uphill. From left to right, if a line is horizontal, that's zero slope. That means you're neither positive nor negative. Okay, so we'll call this positive. And then from left to right, if you're going down, what is that? That is a negative slope. Negative slope. Okay, so do you see what's going on in this interval right here? So on this interval right here, from 0 to 2 is going up on this entire interval. So what's the slope here? It's positive. You have positive slope here. From 0 to 2, it's positive. And then from here, from 2 to 4, it's 0. Okay, it's staying horizontal, it's just horizontal. So the slope here is 0. From 0 to 4, slope is 0. How about from, well, actually, it goes a little bit further. It goes from 0 all the way to 5. So let's extend it a little bit more. So from 0 to 5, it's from 2 all the way to 5, the slope is 0. From 5 to 6, what's happening? From 5 to 6, it's going up. If a line is going up from left to right, that means the slope is what? From 5 to 7, the slope is positive again. So we have positive, 0, positive. What is happening from 7 to 8? From 7 to 8 is horizontal or flat, which means you have 0 slope again. From 8 to 9, what's happening from 8 to 9 is going positive. Why is the slope positive here? The slope is positive there because from left to right, the line is going up. So it's positive here, okay? Now from 9 to 12, this is where the problem was asking us for, from 9 to 12. What's happening from 9 all the way to 12? On this interval, it's flat, horizontal, flat, flat, flat. What is the slope there? 0, okay? From 12 to 14, what's happening? It's going down, down, down. What is the slope if you're going down from left to right? Negative, okay? From 14 to 16, what's happening? From 14 to 16, it goes flat again, it's horizontal. Remember, horizontal is 0 slope, so from 14 to 16 is 0. And then from 16 to 18, it's going up again. So it's going up, up, up. What is the slope here? Going up from left to right is positive slope. So there you have positive. From 18 to 19, flat again. What is the slope there? The slope is 0. And then from 19 to 20, there's a big drop. From 8 miles per hour all the way down to 0. So here it's negative. Okay? So now, what is the connection between the sign and the speed? Now, here's a connection. If you have positive slope, guess what? Your speed is increasing. Okay? It's increasing. If you have 0 slope, you're staying at a constant speed. Constant. Okay? And then when you're decreasing, guess what? When your slope is negative, your speed is decreasing. Okay? So that's the connection right there. So anywhere you have the blues increasing, anywhere you have the blues with a positive slope, your speed is increasing. Anywhere you have the blacks, this flat line, your speed is constant. And anywhere you have the reds, the negative slope, your speed is decreasing. Okay? So don't forget that. Positive slope increasing, 0 slope constant, negative slope decreasing. Okay? All right, so let's take a look at 9 to 12. This is where we're going to focus in on. I was trying to show you everything so you really understand, as opposed to just answering the question. So from 9 to 12, what is happening there? From 9 to 12, you have 0 slope. If you have 0 slope, what is happening with the speed? Is the speed increasing? Is it decreasing or zero? Or constant? If you look at this chart list we have here, zero slope means that the speed is constant. Okay, so let's go ahead and look at our options. She was standing still, that's a no. She was standing still at 0 and 20 only. She was increasing her speed, no. If she's increasing her speed, then the slope here must be positive, but it's not. So we'll cancel that out. She was decreasing her speed, is that true? No, because this would have been negative. It would have been decreasing, going down from left to right, in order for that to indicate that her speed was decreasing, so that's wrong. She was jogging at a constant rate. Voila, this is what we're looking for. She was jogging at a constant rate because the slope is 0. That means the speed was neither increasing nor decreasing. All right, let's take a look at question number 3. It reads, if the area of a rectangle is expressed as x to the 4th minus 9y squared, then the product of the length and the width of the rectangle could be expressed as, you have the options here. Now, one thing you want to note is that the area of a rectangle is the product of the length and the width, okay? A is equal to L times W. Now, these are the steps we're going to use for this problem. We're going to draw a sketch of the rectangle and write down the formula for the area. It's always good to have your formulas in front of you. And then we're going to determine the expression for the product of the length and the width. And then we express it in a different way by factoring, okay? This is a factoring problem. The factoring formula we're going to be using is the difference of squares formula, a squared minus b squared equals a minus b times a plus b. All right, so let's go ahead and get started. Let's go ahead and sketch our rectangle. We have this rectangle right here. So let's call this our length, and this is our width, okay? And then the interior, that is the area, all right? That's the area right there. In this problem, we know that the area is x to the 4th minus 9y squared. Now, what's the formula for area? Area is equal to length times width, all right? Now, the problem is asking us, telling us if the area of the rectangle is expressed as x to the 4th minus 9y squared. So the area is x to the 4 minus 9y squared. Let's plug it in here. So the length times the width is equal to x to the 4th minus 9y squared. Then the product of the length and the width of the rectangle could be expressed as, what is the product of the length and the width? It is the area. It's exactly this right here, okay? So how come we have other things here? Well, the process that was used to alter the look of this expression is factorization, okay? We're just changing how this looks. We're factoring the area expression to see another way of writing the product of the length and the width, all right? So if you notice, x to the 4th is a square because the power is even. 9 is a square because 3 times 3 is 9. Y squared is a square because the power is even. So what is this? This is a difference of squares. All right, so let's go ahead and factor this. How do you factor difference of squares? Well, what you do is you take the square root of the first term and the second term, and you find the sum and the difference of those two terms, okay? So a squared is going to be x to the 4th. Now, what happens when you take the square root of x to the 4th? If you take the square root of a squared, you get a, which means you divide the power by what? 2. So this is a to the 1. What do you get when you divide 4 by 2? By 2, yeah, you get 2. So you have x to the second power. So the square root of x to the 4th is x squared because you simply divide the power by 2. That's a shortcut, okay? All right, b squared. b squared is 9y squared. What are we going to do with this? We're going to take the square root, okay? Because we need to find what b is. So the square root of b squared is b. The square root of 9 is 3 because 3 times 3 is 9. Square root of y squared, divide the power by 2, so you have y to the first power, which is just written as y. So a squared minus b squared is going to be a minus b times a plus b. So we have our a and our b right here. So let me highlight it. So this is our a, and this is our b. So what we're going to do after taking the square root is we're going to write it as a sum and a difference. Okay? So let's do difference first and then a sum. So what is a minus b? A minus b is x squared minus 3y. A minus b. Okay? And then we have to write a sum. A plus b is x squared plus 3y. A plus b. Okay, so this is the area. We haven't changed anything. We just changed the look of it. Okay, if I expand this, what am I going to get? If I expand this, the middle terms will cancel out, and I'll end up with x to the fourth minus 9y squared. Okay, so this is a different way of writing the product of the length and the width, the area. So let's see which option matches the factored state of our area expression. X squared minus 3y times x squared plus 3y. Option number 2 is the correct answer. All right, let's take a look at problem number 4. It reads, which table represents a function? Now, just a quick reminder, if there are repetitions in the x values or the inputs of a table of a relation, then it is not a function. So repetition is not a function. No repetitions, then it is a function. All right, so keep that in mind. Steps. We're going to examine the x's. For this problem, we are focusing our attention on the x's. So the input entry of each table, that's what we're going to be focusing on just the x's, okay? So when we examine all the x's, step 2, anyone with repetitions in the x's is not a function and should be eliminated as a candidate, all right, for the answer, because we're looking for what is. Whatever is a function has no repetitions. So after we're done eliminating the ones with repetitions, the table that has no repetitions in the x's is the answer, okay? All right, so let's take a look at option 1. We have 2. Is there any other 2? Yes, there's a 2 repetition. So since there are repetitions, is this a function? It's not, because a function assigns every input to exactly one output. Here, 2 is being assigned to 2 different outputs. That's not acceptable. Option 2, we have 0. Is there any other 0? Yes. We have repetition in the x's. That is not an answer. Number 3, is there any other 3? No. 5, any other 5s? No. 7, any other 7s? No. 9, any other 9s? No. Excellent. This is the answer. We can see why 4 is not an answer, because 0 is repeated. So that's not the answer. So when you're determining if a relation is a function or not, take a look at the inputs or the x's and make sure that there are no repetitions there. Then it will be a function. Okay? All right, let's take a look at problem 5. It says, which inequality is represented in the graph below? So we have a solid line that's shaded. This is a graph of a linear inequality. Now, one thing you want to note is that when determining the slope of a graph graphically, as we will be doing momentarily, you want to pick points that lie perfectly on the intersection of coordinate grids. Okay, what am I saying? This is a point that lies on the intersection of the coordinate grids. This is a point. So you want to pick a point on the line that lies on the intersection. Like, let's say you have a point there that lies on a line. That's no good. Okay? So that helps you have whole numbers to work with in your computations. Steps. First thing we'll do is we're going to find the slope and the y-intercept from the graph. Okay? Then we're going to determine the orientation of the inequality based on the direction of the shading. So you can see, is it shaded above or below? Okay. And then step 3, we're going to combine the results from 1 and 2 to form a linear inequality using one of these formulas right here. We're going to narrow it down to one. All right, so we have M and B, just plug them in here. Pick the right one based on the shading, and you're done. Okay? All right, let's start with step one. Find the slope and the y-intercept. What is the slope? We know the slope is rise over run, right? Slope, which is M, is rise over run. Okay, now we want to pick 2 points. This is where it's very important. Remember, we talked about it earlier. Your points have to be perfect. They have to lie on the intersection of the coordinate grid. Let's pick a point. I like this point right here. Next point. How about that? How does that look? That point is no good. Why is it no good? Well, it lies on the horizontal coordinate grid, but it doesn't lie on the vertical coordinate grid, so take that out. Don't do that, okay? You want to pick a perfect point. So how about this one right here? That's perfect because it lies on the horizontal and vertical coordinate grid. Okay, that's how you pick your points. Now let's do the rise. We're going from -4 to 1. 1, 2, 3. Since you're counting down, it's -3. Does the sign matter? Absolutely. Okay, if you're going down, that's a negative slope. So your rise is -3. What's your run? Your run is, you always run to the right, okay? So your run is 1, +1, so it's -3 over +1, so rise over run is -3. That's the slope. What do we need next? We need the y-intercept. Y-intercept is also known as your B. That is where the graph intersects the y-axis, and we can see that here is your y-intercept, 4. Okay? So B is 4. So we have 2 components down. Next thing we need is the inequality. Okay? What's being shaded here is the shading is above the line. Okay, think about this as a roof in a house. This is shading is above. So what does above mean? Above means greater than. And since the line is solid, it's going to be equal to. Okay, so the inequality symbol we're using is greater than or equal to. So we have 2 choices here. The one that we are going to use is this one right here. So cancel that. This is what we're using, greater than or equal to, because the shading is above the line. All right. So we have y equal. We have y is greater than or equal to mx plus b. M is -3, b is 4. We're going to input these values into this equation right here. Okay. So we have y is greater than or equal to -3x plus the b value, which is 4. Okay, so just take this -3, put right here, and then take 4 and put it on the b spot. Okay, and then you have y is greater than or equal to -3x plus 4. Let's see what our correct answer is. Oh, where are you? There you are. Okay, y is greater than or equal to -3x plus 4. Our answer is option number 1. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found this tutorial beneficial to you, do give us a thumbs up. We'll appreciate your positive feedback. If you have any questions whatsoever about any questions in this review series or the Algebra 1 Common Core exam in general, just place a comment in the comment section below and we'll be glad to address it as soon as possible. Please subscribe to our channel so you can get updates to the remainder of this review series. Don't forget to check out our interactive practice test to sharpen your skills for the upcoming Regents exam. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.